Hello everybody, my name is Aaron Stannard. I am the Chief Technology Officer and co-founder of Petabridge, a company that provides Akka.Net services, training, and support. And I'm also one of the co-founders of the Akka.Net project. And today we're going to talk about what I think is one of the absolutely coolest things Akka.Net can do, which is the ability to deploy actors remotely over the network. So let's talk a little bit about Akka.Net's extensibility model. We have this concept that we've expressed as part of Petabridge of the Home Depot extensibility model. And if you're not from the United States, the Home Depot is like the world's largest hardware store. It has everything from different types of knobs and handles for doors, to sinks, to paint, to lumber, to gardening supplies, you name it. If you want to build a house, you can just go and pick the things you need from Home Depot and make it work. And the same idea applies to your Akka.Net apps. All you need to build a basic Akka.Net app is the core NuGet package and the common language runtime. You don't need anything else to make it work. But if you want to integrate with your favorite dependency injection library, your favorite .NET logging library, or a unit testing framework like NUnit or XUnit, Akka.Net has additional modules that you can use to add those capabilities to your Akka.Net applications. So we have a couple dozen different little extensibility points within Akka.Net. And we're going to talk about the most powerful module of all today, which is Akka.Remote. And what Akka.Remote does, it takes all of the capabilities that you got in the core Akka.Net package and then allows them to work transparently over the network. So if you want to do something like communicate with actors on remote systems, so send a message to a remote actor or a remote actor selection that exists somewhere else on the network, Akka.Remote makes that possible. Or if you want to deploy an actor onto some process that isn't the local process making the deployment call, you can do that with Akka.Remote. And that's the focus of today's video. And then the last thing that Akka.Remote allows you to do is to configure and support multiple network transports. So if you want to use a combination of TCP and UDP sockets for whatever reason, Akka.Remote makes that possible too. So let's talk a little bit about how you actually enable and use Akka.Remote within your own apps. All right, so the process of enabling Akka.Remote is as simple as using NuGet. So the first thing you need to do is install the Akka.Remote NuGet package. So that's what contains all the binaries that are needed to make this work. And then within your HOCON configuration, when you're starting up your Akka.Net application, you need to enable the Remote Actor Ref provider. And I'll show you how to do that in just a moment. The next thing you need to do is enable at least one transport. So Akka.Remote wouldn't be very useful if it didn't have some way of communicating over the network. Then you need to configure an address for each transport. So you need some IP address and port combination that each of the transports can use. And then you just start your actor system. And that's all it really takes to turn on Akka.Remote. It's pretty simple. And the configuration details for how you turn it on aren't so bad either. So one thing you'll notice is that in both the server and the client in this sample, the Akka.Actor.Provider is set to this fully qualified type name here, the Akka.Remote Actor Ref provider. The reason why this is a fully qualified name, FQN shorthand for that, the reason why this is a fully qualified name is because Akka.Net will dynamically load this at runtime from the Akka.Remote library. So there's a lot of different extensibility points such as loggers, even network transports for Akka.Remote and serializers, where Akka.Remote can load user-defined types from configuration and use those at runtime without needing to be linked to them beforehand. So that's how Akka.Remote is able to provide this remote actor reference provider that the actor system will use. So the remote actor ref provider is basically the piece of plumbing that makes all the remoting capabilities work. Next, we have a remote section that defines all of the transports that we're going to use. So here we're using a Helios.tcp transport. Helios is the socket server that comes with Akka.Remote by default. Helios supports both UDP and TCP sockets, and it's high performance. We don't have a UDP transport enabled just yet inside Akka.Net. We'll add that eventually, but for the most part, 99.99% of our users who are using Akka.Remote are fine with TCP. So the first thing you'll notice that we do is we configure the ports for the Helios transport for the server to be this fixed number, 8081, and we define the port for the client to be 0. Now the reason for that is that the server handles inbound connections from clients. Therefore, the server's address needs to be well known. So the clients will be configured to reach out to that server and contact it. So the server must have a fixed port and IP address. The clients, on the other hand, when they pick port 0, that means the operating system will pick a randomly available free port for them. So that allows us to start multiple clients simultaneously from within Visual Studio or the command line, and they can all independently connect to the server without having to be reconfigured. So that's why we use port 0 for the client. And then we just use localhost as the IP address for now. So when you enable a remote transport, it actually can have an impact on the address and the way you can address remote actors. So this is what a local actor path looks like using a local address. So we have the default Akka protocol, we have the name of our actor system, and then we have the little path that represents where a particular actor sits on the hierarchy. With Akka.Remote, the address looks a little different. First is that the protocol gets augmented with the scheme of the transport that we're using. So the scheme of the TCP transport is .tcp. The scheme of a UDP transport might be .udp, and so forth. Then you have the actor system, just as we did before. Then we also go and add this address to the name, to the actor path itself. And so this address represents the inbound endpoint that we configured inside our configuration section. So every time we want to go and contact the server, that's going to say localhost 9001 port or port 8081, whatever port we explicitly configured. If we picked port 0, then that address will contain the random port that the operating system picked for us. So this remote address is important because in order for us to establish contact between two remote systems, we need to know how we should address those messages. So the way a remote association works is, let's say we have two servers that are running across the network. One server who knows the second server's address will send a message, and that's going to be what will create the association between two systems. An association is a technical term that Akka uses for describing a connection between two remote actor systems, and you should look at our internals video on how associations are formed if you want more detail on that. The second system will reply back and say, yes, let's do that. So at this point, the two systems now share an association. They can freely send messages or do remote deployments back and forth to each other with no problems. And so this takes us to the two ways you can initiate a remote connection between systems. When you want one actor system to be able to communicate another, you have to contact it. Connections are instantiated lazily inside Akka.Remote. So the two ways you actually initiate the association process between two remote systems is by either sending a message via an actor selection that has one of those full remote addresses like I showed you earlier, or you try to do a remote deployment onto another system. So we're going to focus on the remote deployment section for the rest of this video. Okay, so let's talk about remotely deploying actors and what that actually means. So the concept of deploying an actor is that you create an actor instance with configured properties that get specified in the Akka.Actor.Deployment section of your HOCON configuration. And we'll review an example of that in a moment. And then once the actor instance that you defined has been created, so if you created an actor of type foo, once the foo actor gets initiated and is configured with all of its properties, such as whether or not this actor is running under a router, and what dispatcher this actor is using, and what mailbox it's using, etc. Then you finally get an actor reference to that actor. So the iActorRef class is what we use for holding on to an actor reference. So one of the interesting things that Akka.Remote does is it turns the location of an actor on the network into a deployment detail. So where an actor lives is now something that you can configure through HOCON configuration or through procedural code. So here's an example of what remote deployment looks like. So let's say we have our two actor systems again. First actor system contacts the second and says, hey, could you create a foo actor for me? And the second system does. It creates a foo actor, and then it sends back an actor reference to the first system. So the first system can now communicate to that actor as though it were a local actor, even though it technically exists over the network on system 2. So let's look at some code and see how this actually works. Okay, so I have Visual Studio open here, and this is a little remote deployment sample that I put together. And the first thing I want to point out before we dive into the code is the structure of the project. You'll notice that we have 3 projects. Deployer, this is the actor system that's going to be doing the deploying over the network. We have shared, which defines a couple of classes that we'll look at in a moment. But this library gets shared between deployer and deploy target. And then there's deploy target. This is our server. This is the application that's going to be deployed onto. So let's go ahead and take a look at the classes that make up this example. So let me go and blow that up. And I'll zoom in just a bit. All right. So this is the deploy target project. So the first thing to notice is that rather than loading the HOCON configuration from app.config, we're just doing it right here, parsing it from a string. Makes the sample a little easier to read. We're initiating the remote actor reference provider, just like we talked about earlier. And we're creating a Helios TCP transport on port 8090. So this is a well-known port. But what isn't happening here? And the answer is that this actor system isn't creating any actors at all. It's totally blank, just sitting there, not doing anything. And then the next thing to take a look at is our echo actor. So this is a little actor class that I'm going to zoom in a bit here. This is an actor class that I defined that just simply takes a message of type hello, writes who the sender was and the message on the command line, and then sends the message back to the original sender. So it just echoes the message back. And the hello class is pretty straightforward. It's just a wrapper around a string. But then here we have the remote deployer. So this is the actor system that's going to be doing the deployment onto the deploy target. So we have a little actor here called a hello actor. It takes a reference to a remote actor. And on a timer, it will go and schedule itself to repeatedly send a hello message over the network. So every time we receive this say hello message here, we're going to create a new hello object. And we're going to go ahead and tell it hello plus some updated counter value that we're incrementing. So that's what this actor does. Then here you can also see that we have a pretty thin actor system. So we create an actor system called deployer. We enable the remote actor ref provider. And then a couple of interesting things happen. Inside the deployment section, we go and create an actor called remote echo. And we specify this property, remote equals Akka.TCP, deploy target at localhost 8090. What does that mean? We'll find out in a moment. Then we define a remoting section here, and we specify the port to 0. That way I can fire up multiple deployer instances simultaneously, and we can see what happens. And then, just to show you a couple of different ways of doing a remote actor deployment, I go and take the TCP address for the deploy target, and I go and parse that into an address object here, so I can use it within procedural code. So first thing you're going to notice is that we are going to create an echo actor here. We're going to create props for it, and we're going to go ahead and specify the name remote echo, which should correspond to what we just defined in our HOCON configuration section here. And then down here, you'll notice that we have a little bit more code. We go ahead and create props, and then we do this little with deploy method here. And we do with deploy in scope, and then we pass in a remote scope. And this remote scope has the address that we parsed out for the remote system. And we call this code remote echo. Okay, so just remember those names for a moment. And then down here, you can see where we create 2 hello actors that are responsible for talking to the actor references we get back from these 2 samples here. So I'm going to go ahead and dock this back into Visual Studio, and we're going to start up the sample. All right, so let's go ahead and start both the deployer and the deploy target up. Okay, so this is the deploy target on the right and the deployer on the left. Now, one thing you can notice right away is that the deploy target, which had no actors, is sitting here printing messages out. Whoa, what's up with that? And the answer is that we were able to successfully instantiate an echo actor over the network. And the two, we instantiated 2 echo actors and 2 hello actors. And you can see here that the echo actor running on the deploy target is printing messages from 2 different actors running on the deployer process. You can see the Akka.TCP/deployer at localhost, and then this random port number that the OS picked for us. Then we see 2 different actor names, B and C, showing up here. So we can see that messages are being successfully sent over the network. Now, if we go and look at the deployer, we can see a pretty interesting reply back from the deploy target. We see that we're receiving the messages that we sent echoed back to us from an actor at this address, Akka.TCP/deploy target at localhost 8090/remote Akka.TCP, blah, blah, blah. The thing that's worth pointing out is this part of the path right here represents the deploy target. But then after that, we have this /remote little stub here on the actor path. And then the rest of the path actually represents our local address information inside this instance of the deployer. So, and then we see the username is /user/remote echo, or /code.remote echo for the remote actor that we deployed purely in code. Now, what happens if we go and start a second deployer instance here? All right, so here's our new deployer instance. And boom, we can see some new messages starting to show up here from an actor at a totally different port number this time. Well, that's because this guy just started up and the operating system picked another random port for him. One thing that's worth noting here is that these guys are both deploying actors onto this system with the exact same name. So the reason why there's no name collision there at all is the full path of that actor includes the address of the system that did the deployment onto it. So one other thing that's worth noting, I'm going to go ahead and shut the processes down here, is that this actor, remote echo and code.remote echo both have names that are local. So what happens if I send an actor selection here? So if I do system.actor of, actually I guess we'll do system.actor selection. And we'll do /user/remote echo. And then we'll tell it that hello class that we've been using. So hello, hi from selection. So this piece of code right here looks like we're sending a message to a local actor. But in reality, this is going to get delivered to that remote actor we deployed over the network. So let's see what happens here. And boom, you can see that the very first message we received is from the no sender address. So there's no actual actor we can reply back to here, but we can see the address of the system that sent it. And it said, hi from selection. All right, so in that code sample that we put together, you could see how a local actor, everything that had the makings of a local actor, we're even able to send a selection to a purely local address, and that message got delivered over the network to an actor that was actually running on the deploy target machine. So what actually makes that work under the hood? So we're going to go ahead and give you a view of some of the internals that are going on that make all this possible. So we have the 2 actor systems here, deployer on the left and deploy target on the right. So a call comes in to go and create an echo actor on deploy target. And the props specify that this actor needs to be created on deploy target's remote address over the network. So the remote actor ref provider creates a remote actor ref that will map to a live actor that lives on the deploy target system. So we get this little remote actor ref back right away. And then we serialize the props and the deployment info into a special type of message that we can send over the network. And so that gets handed off to what's called the endpoint writer. This is one of the built-in system actors that we talk about in our internals video on how associations work. So the endpoint writer transmits that data over the configured transport to the endpoint reader that belongs to the remote actor system. And then the endpoint reader will deserialize the props and the deployment information. And a special built-in actor inside the remote actor ref provider called the remote daemon will go and create that echo actor on the remote system. And then from that point onward, all messages that are sent to the original remote actor reference that we received on the endpoint that was deploying the actor will all be delivered to that actor over the network. So this little remote actor reference has the appearance of being a local actor, even though it really maps to something that exists over the network. And this is one of those instances where you can really see how location transparency can be powerful inside the context of Akka.net. The ability to go and deploy code remotely over the network and still have it appear local allows us to program our actors and anything that takes an iActor reference to not need to make the distinction between what is local and what is remote. That detail is totally handled by the Akka.Remote framework for us. So, a couple of important things to know about remote deployment. First is that remote actor names are determined by the system that is doing the deploying. That's why we're able to spin up multiple deployer instances and not have any name collisions. The name of the actor system and the local address of its binding is what tells, it gets factored into the full name of the system that's being deployed onto. So since addresses are unique and since actor names are unique per every local system, if we have 40 instances of the deployed target, all try to deploy the same echo actor name, none of them will collide with each other. And the local actor system is going to know if you try to deploy the same actor twice. That it works exactly the same way as if you try to create the same in-memory actor twice if you're using just the normal Akka.net package. So that's no different. So names are determined by the system doing the deploying. The second is that actor and message types must be present on both deployer and deployee. The C# or F# type of the actor that is being deployed and the types of the arguments that are being passed into its props and the types of messages that actor receives must be shared between the system doing the deploying and the deployer. That's why we had that shared middleware library from before. And then the final point is that all constructor arguments for remote deployed actors must be serializable. Don't deploy anything that needs dependency injection or needs a SQL Server connection or needs access to some resource that can't be serialized, like a Lambda or a disposable resource like a performance counter. You're not going to be able to deploy any of those things over the network. But there are strategies for being able to deploy actors with complex requirements over the network too. But that's a subject for a more advanced video. So that wraps it up for this particular video. And what I'd like to point you to is that if you really enjoyed this content, if you're interested in learning more, go do our Intro to Akka.net bootcamp. So that's at learnakka.net is the address for that. And that covers all the Akka.net basics and teaches you how to build applications using actors. If you want to learn more about Akka.Remote or you want to learn about Akka.Cluster, any of the other sort of advanced concepts, we offer professional trainings on the subject. We offer a few different times a month. You can go to petabridge.com/training to get more info on those. Thanks again for watching, and please leave any comments you have for us in the comments section. All right, thank you very much.